Hi guys, and welcome to another devcast. Some of you have asked me about Machina that I'm mentioning in my other videos that I'm working on, so I've decided to do a sneak peek into it. Uh, Machina as a framework resolves for me a few functions. Firstly, I'm using it in parallel to develop with Dash system, just to like check some of the paradigms I'm using in Dash and in development of Dash, just to verify them basically. And secondary, it should be a procedural generation system. I've actually started working on it a couple of years ago. Then I paused it since I was waiting for the Unity dot system to make it faster, but it never materialized. So because the dot system still doesn't work, and it will not even work for some future, especially inside the editor, because the code execution inside the editor is quite different for the editor extensions than for the final build project. So I've decided to recreate Machina now that I'm working on Dash, and it is a procedural system, node-based procedural system for basically for geometry generation or modification. It's similar to other systems, for example, like Houdini, but its advantage over something like Houdini is that this will execute at runtime as well, whereas in Houdini you can work with the Houdini engine inside Unity, but only in editor time. Then you need to bake the stuff to use it inside the final build project, but when it comes to Machina, you can just set the procedural generation to run at runtime, or you can even move it to server side and you can generate your geometry on a server. It's not bound to any, it's not bound to Unity editor in that way. So let's just, as I said, this will be a sneak peek, so I will show you some stuff generated in Machina, and I will show you the approach. So it's very similar. The editor is quite similar to Dash system, uh, but there are some radical differences outside of the obvious visual differences, like the inputs are vertical, not horizontal, and stuff like that. The Machina is synchronous, so once you execute a node, a procedural node, it will basically not go forward like in a Dash system, but it will gather, so it will go back through the graph and it will gather all the inputs it needs. So this is the final node. Once you have it selected, it will uh, render the wireframe for it, but now we don't have any render node. This will set it to render, to the final render node. This is the output actually, but it is generated using all these nodes. So it goes through, this is the input, so it goes through all the inputs and gathers the data needed to generate basically this final mesh. So let's go into a bit of detail. There are separate parts for this scaffold. I'm generating basically a procedural scaffold here, so you can change it in any way you want. So there are some, you can even change the floor type. There are some parameters. These parameters I just created. You can have different parameters if you want to. So it's done completely in the runtime. So if I change the parameter, it will invalidate the graph and it will generate the geometry down to the vertices, down to the edges and normals and UVs, and it will basically regenerate the whole mesh. So let's go back to our simple scaffold. So there, one of the parts is flooring, which flooring I mean this. If I switch to this node, you will see that this is a single floor for one of the scaffold parts. Then it will be here it is copied into the points based on the attributes through the whole scaffolds. But this is the single floor, and there are two types of floors because I can basically change them. This is the horizontal, and then there is the vertical, or this is the vertical, and then there is this horizontal type. So it starts with a single box that in both types, and it copies this box over a line of points. This box in the vertical type is also pre-transformed to be vertical, obviously, because if we copied it like this, it would just look differently. So let me show you. If I pass this transform, it would just change this to 4 boxes on top of each other. So I will just enable this. Similarly here, we just copy this box over this line. I can change the parameter of these lines, but I'm gathering the parameters for it from my global parameters for the scaffold itself. So it basically scales to the scaffold needs. If there are fewer segments, it should be bigger, and so on. So copy to points basically gathers the second input and then copies it over the points from first input. So it will just gather this box and copy it to these 6 points. There is a special parameter here that it should execute for each point. If I am not executing for each point, it will basically cache the first input or the first execution of the second input. And as you can see, I am using a special parameter inside my transform to basically randomly rotate it a bit, just to rotate it around the y-axis a bit to make it more random. But if I am executing only once per point, all the boxes, all the puts will be rotated to the same amount because it's not 6 different geometries, it's just the first one cached. So I'm using a special parameter to execute per point, and now as you can see they are executed and rotated uh, each to their own value. I'm also using seeding inside Machina, so if you execute it, it will always generate the same geometry. If you want to change the seed, you can basically change the parameter for that node, and it will change the seed for that node. If I'm executing per point, I am also injecting this seed of the copy to points. So if I change this seed, it will also change the seed for each input execution. Okay, so this is the floor. There is one more node, which is a switch node, which basically takes X amount of inputs, and you say which of them, it's an integer index, which of them should be actually used. So I'm gathering this from the global attribute, which is the floor type, and as you can see, if I change it, my final output render mode, so it will basically pick this one or the left one or the right one. You can have 3 different ones if you want to. Secondly, I have beams, which are these pillars for the scaffold. They are very similar. This is a simple geometry for the tube. I'm just generating 2 lines that basically generate a grid. I copy the points, one of the line to the other, and then I am offsetting them because there are 2 parts, the front part and the back part. So I take this geometry and generate 2 separate nodes, and then I merge them together once again. So I actually have an additional dimension to the grid, and then I copy this tube over these points, so it will generate the beams. Very similarly, I will generate these stabilizers, additional wood that I added to to the geometry right under the flooring, and all this is actually driven again by these global parameters. So the position is offsetted by the height and vertical segments a bit. Also it is subtracted a small value, so it's not at the same position as the floor, but slightly under it. Again, I have these horizontal stabilizers, which is once again a piece of wood that should uh, like seem to hold the floor together a bit more. And very similarly, I'm actually using a box with two transforms, and I'm merging them. So it's a slightly different approach here, where I basically uh, the points, I duplicated the points to the additional dimensions, so I had more points and one tube. What I am doing here is I have two stabilizers, so I already have the geometry duplicated, and the copy to points is only one grid. So it's just to show you a different approach how you can do it. And finally, I have these rails, just to add more randomization to the visualization of the scaffold, and it is driven once again by the global parameters, and there is a randomized rotation, slide rotation. So as you can see, there is a different rotation to these rails. So if I change the seed of the copy to points, as I said, it will also change the seed for the executed input, and you will have a different output. So you can just try various seeds for the final visualization. And finally, I have this small ladder here, which is a separate node to the final merge, because if I check this, it's without the ladder. Also, it doesn't have a material here. I'm adding the material as a final node. So this is the final geometry, and here I'm adding a simple material. So this ladder is again generated from a single a single cube actually, which will be transformed in this way, then copied over these points to generate something like this, and transformed the same box is transformed this way, and using additional transform to basically duplicate it in a final merge and then merge it all together. And then I am transforming to the final position. So I'm getting this scaffold. I can also generate this on an additional input geometry from Unity. So if I have, for example, a building that I want to attach scaffold to, I can basically take that mesh input and generate it as I need. So let me show you further things. This is a tree generated by Machina. So let's open the editor. There are additional things here, but this is the tree. I'm using textures from, I think this is from Synthes or Bitcam. I think it's Synthes. I have various assets here, but for now, what I show you, I'm not using any geometry from the assets, but I'm using this leaf texture. So this whole tree is started. Let me disable this for output. So it started from this quad or a grid basically. Then I'm just taking and rotating the grid, and then I'm editing its vertices to make it a bit different, to basically start putting out the geometry for the branches. Then additional edit to just taper it a bit more. I'm also bending it, which is a bend node where you can specify an angle and starting position for the. This is actually showing you the axis the bend board works. So this is the bending axis, and this is the axis where the bend happens. This is where the bend happens around this axis basically. Then I'm putting a material here. As you can see, if I select this as output, there is no material here. So I set a material for this branch. I change the UV edit because if I take these materials from Synthes as is, you see there are these kind of texels. I don't know what they mean, but they shouldn't be there. So I'm just editing the UVs here to just get rid of them by simple translate. And I am copying it to the points. Oh, there is some issue now. Don't know what happened, so I will be back. Okay, I figured out the issue. Actually, I was changing a model of one of the nodes right before recording this video to parameterize some of its properties, so the serialization of that node was outside of sync. I just reserialized, so let me show you. Now I'm just copying the branch to points. I will show you the output. So these are the leaves basically. So let me show you what I'm doing here. I'm just generating this disable these outputs. I'm generating this tube with 6 segments, small radius. So let's say I will just go here, and it branches here. But let's focus on this branch that we will use to copy the points. So I'm transforming it a bit higher because I will use the same tube for the trunk of the tree. So uh, I'm moving it a bit higher because the branches should be higher. You can parameterize it if you want to have them at the bottom as well. Then I'm bending it in a Y position. So this will basically rotate these points around this axis. Why I'm doing this? Because I will use. I will show you. I will use uh, the actually the normal, because the normal is let me show you the normals. These are the normals if I don't rotate it, and if I rotate it, you see these normals are rotated slightly. You can just change it, so they are not the all uniform like this. So I don't want the branches to be too uniform, so I will just rotate the points, so it will rotate the normals as well. Then if I didn't, I am using a special attribute node that will add additional parameter, additional attribute inside the node graph, inside the node flow data that you are familiar from, which is similar to Dash, which is called scale. It will scale, it will add this float value into the node flow data based on, as you can see, it will be not a float value, it will actually be vector 3, but based on the height of the vertices, or the height or the distance of this vertex from the floor. So basically, the higher it is, the smaller the scale. And why? If I just show you the output, if I just pass this, you see that these branches will be copied uh, just as they look here. But since this copy to point recognize the scale attribute inside the node graph, if it encounters it, it will automatically use it. So just basically this will scale our branches to from smaller to bigger. So just so it looks like a tree actually. We could also introduce additional rotation and more randomization. It's perfectly doable. I just wanted to keep it somewhat simple. So, and finally, we have the trunk. I will just disable this. So we have a trunk which is the same tube, but highly scaled. So it just covers the bottom of the tree and as well as the top of the tree. I will use a taper node to just taper it a bit to look more like a trunk basically. And then I'll add the material of a trunk here, and I will merge it into a final tree. What I am doing here with the material group is basically resetting the material for this geometry to an index 1 instead of 0. For now, this is how I approach material generation, because this will basically, to see it in Unity, it will generate a Unity mesh with two submeshes with two different materials, and it needs to know which of the material is first and which of these the material is second. So this is why I'm using material group to set the index. So because it doesn't it works on per vertex basis, in each node manipulates the geometry and all, but it uses its own internal classes and instances for a geometry. It doesn't use Unity Mesh. The Unity Mesh is only used to see the output. That's why it can run even on server without Unity, basically, even though there are some dependencies at the moment, but the Unity Mesh is not one of them. And this is also why I avoided meshes. Another reason is to have it multi-threaded. It's not multi-threaded yet, but I'm preparing it to be multi-threaded, and you can't multi-thread the mesh generation in Unity. You can do it in jobs, but I want to avoid jobs. I want to create basically a C# code to be portable to anywhere and to generate meshes. And to have them multi-threaded, we need to avoid Unity meshes. I also avoid, for example, Unity random, because it still needs to run on the main thread and it's a Unity specific random, so I'm using the C# system random. Okay, that was for the tree. Let me show you another thing. You can also use Unity meshes as an input. So here, for example, uh, let me show you this. I'm using, this is the tree, this is actually original tree from Polygon Nature, from Synthes. So I'm not generating this tree. It's from the asset store we bought. So I can use this mesh if I don't want to generate anything, and then plug it inside Machina and use it to generate something like this, which is basically some kind of forest or something. So let me show you. This basically takes the tree, and since I didn't really like the uniformity of the tree, I added some modifications on it. And this is great what you can do in Machina. You can just take a specific assets and add additional modifications on them. So not all the trees are same height or stuff like that. So I'm just creating random transformation. So it will be a random rotation, obviously, but also a random scale. That's why not all the trees are the same size, even though the asset actually is the same size. And also I'm taking the tree and I'm bending it using a bend node, which goes through the vertices, as I said, in an axis and bends them. So as you can see, all the trees are bent in some way. And I'm copying it to 2 points. Also, I'm executing per point as usual. So all the bends and the transform and scales are executed separately. What I'm doing here to generate the points for the small forest, I'm using a Perlin noise node to generate some points, but these points are on a plane. Obviously is a 2D Perlin noise. So then I'm taking additionally Unity mesh, which is this basically ground. I'm transforming it so it fits my scenario, my scale, and then I'm using this Unity mesh for output, obviously, to generate the visual, but I'm also using them as an input to a project node, which projects the Perlin noise points into it. So it will project so basically the trees are not generated on the floor, but they are generated exactly on the mesh. So if the mesh is higher, smaller, or there is a different geometry, it will project the nodes the points onto the mesh. There is a slight offset which I specified here, just to be sure that the trees are inside the ground. And then I'm copying this over the points, as I said, and then finally I have this small forest. I can generate more parallel noise points to have more trees. And this is generated per vertex, so we are also actually looking at 250,000 triangles, and which is on CPU generated and modified basically. So not just generated. I can plug this tree here. I think this one should do the trick. It's a different tree. There is not that much randomization, as you can see, but now it's generating the trees as well. There are a lot of more triangles from the basic one. I would definitely add more randomization into this tree to make it more lively, like this one. So let's go back to smaller numbers. I will show you some other stuff I have here. So I will plug this. I have three meshes here. Let me disable the render. Three meshes is there are graves. So three different graves. I'm using switch node with random, so it will basically pick a grave using a random. Then I will plug it here. Let me show you. So it just picks the graves. So I basically want to generate a cemetery or something like that. I'll add more graves. And finally, let's say I have another Unity mesh, which is a bigger grave or a building inside a cemetery. So I want to put it into a middle of the cemetery, but I don't want the graves to be generated inside the building. I should avoid these points. So as I said, the Machina is procedural. So what we can do actually is use a sphere with a transform and a special node which will basically generate a volume of some name or a group of some name based on the volume. So I can specify by default it will basically take the points we have, check it against the volume, which is our sphere, and all the points inside the volume will be added to this group outside. Well, it's called outside, so since I'm inverting it, so it will basically invert all the points that are outside of this volume will be generated into this group. So, and I want to take this group and plug it into our points. As you can see, it still doesn't do anything, but I can specify that I have this group here that should be taken into account instead of all the points. And as you can see, there are these points that don't generate graves because I'm just using the outside group. And if I move this, it will automatically remove graves inside the sphere. This randomization of the graves you can see here, even though it's seeded, so it always generates the same items, is happening because they actually reindex. Because if I change uh, this point, it has a different index. So it's still, as you can see, it's still the same. It's still here, for example, the grave, but it will have just a different index. So there is an approach to avoid this, but it's outside of the scope of this video. So, and then we can have this mesh here. I will activate this connection and it will be inside the sphere. There is an additional functionality that I added to Dash this weekend as well, which basically links these two transforms. So there is a special function that can be used inside the parameterized expression that will tell this position that it should actually reference r underscore means that is a reference, and this string position is the property we are referencing. Since let me show you, I will enable the IDs. This is a transform 6 node, so this tells that we should reference the transform 6 node and its property position. I mean, if its property position is the same type as this property we are trying to assign to the reference, it will use it. So if I move this transform, it will automatically move this transform as well. And we can have this position reference to one node and its rotation, for example, reference to another. This doesn't mean that this transform is a copy or a reference of this transform. We are just referencing the property. Also, if you are referencing a property that is also an expression, it will execute this expression. I added a functionality of nested expression evaluation, but there is obviously an issue inside, for example, Dash and Machina that needs to be taken into account, that this expression anywhere can read an attribute for a flow data. So if there is, for example, there was an attribute here from a sphere and it would be read inside this expression, inside this transform, it wouldn't apply to the evaluation of that same expression inside this branch of the graph. So it will execute the evaluation of the node or of the expression based on data inside this branch of the graph. So I will think about maybe evaluating inputs, but this can lead into very nested, deeply nested and looped expression evaluation. So for now, the expression, if it's an reference expression, it will be basically rescoped to this node and evaluated here. As you can see, I cannot even move this because it's taken as a reference here. So I need to go here and move the geometry there. These assets are from Bitgam, definitely these graves. So that's a sneak peek into Machina, uh, which is a node-based procedural system. It's not out yet. I'm still working on it in parallel with Dash. Uh, Dash is out. You can try it. There is a lot of similarities, but it has a different functionality and it's asynchronous, whereas this is synchronous. So if there is any feedback to this or questions to this or something that you would like to see in a system like this, I'm always open into discussions about it or any ideas are welcome. So that's all for now. There will be some other sneak peeks as well because there is a lot of things that this can actually do already because I plugged my voxel stuff into it. I plugged my skinned mesh stuff into it, so I can actually, for example, blend shape active skeletons using a Machina graph without using blend shapes. So this will basically modify a skinned mesh on the fly and stuff like that. So uh, I will show you in other sneak peeks. And if you are interested in things when it comes to procedural generation, just hit me up and we can discuss it. So that's all for now and thanks for watching.